Okay, so this is the problem out of the ThinkDo book about pinworms. This is about proportions. It's in the proportions section. But what I notice in here is they aren't telling me anything about standard deviations and means. So that's another sign that this is about proportions. This is like the problem in WebAssign, except this is static numbers. So I'm gonna make a recording about this one. Okay, so we're trying to make a point estimate for the proportion of all adults with pinworms. Well, I don't know how many adults, what proportion of adults have pinworms, so I'm going to use the sample result to make my best guess, make my point estimate. Because I did that one sample, and we'll use that to make a guess. So I see there were 72 people that had pinworms out of 800. So if I make that a decimal, let's see. What is 72 divided by 100? By 800, sorry. So 100 I could have done. Actually, I probably could do this in my head. Is it 9%? Yeah, 0.09. All right, and we can certainly write that as a percentage. We can also just write it actually, I was going to do about equal to. It's exactly 9%. So that's 9% or 0.09. Okay, so that's about 9% of the people have infected with pinworms based on the sample. So what's the 90% confidence interval for the proportion of all adults with pinworms? Well, we have to think back. If you look in the book and in the sections to get the confidence interval, you take your point estimate plus or minus the margin of error. And the way we get the margin of error is we have to have some critical value of z, and that tells us how many standard deviations to go away from the mean, either side of it, so we can be 90% confident that so 90% of all the samples of size 800 would have an average that fall in there, in that range. So z star times, then we use p hat times q, or 1 minus p hat, all over the sample size, and then we take the square root. Well, we know p hat's 0.09. We know the z star number is, well, if you look in your textbook on page 288, there's that big normal curve table. And what Dr. Stevens has done for us very nicely is he's broken out some of these z-scores already. Now, these occur because a z-score of 1.645 and negative 1.645 has 90% of the distribution falling in between those two numbers, just like a z-score of negative 1.96 and positive 1.96 contain 95% of them. So all we have to do is our critical value of z is the 1.645. So 1.645. And then because we don't know anything about the population other than the sample, we're going to do 0.09 times, let's make a decimal, 1 minus 0.09, which I think is 0.91, all over 800. And I'm going to take the square root. And now I'm going to do that calculation. Let's see here. Now I'm going to do 0.09 times 0.91. Then we divide that answer by 800. Not 8,000, Dan, 800. Let's see. Now I'm going to take the square root of that. I don't know if you remember from algebra, but raising something to the 1/2 power is the same as taking the square root instead of having to hunt for the keys. So that's the standard deviation for this distribution, and we want to have 1.645 of those either side of the mean, so we'll times that by 1.645. And this number here is our margin of error. So 0.09 plus or minus 0.017. I'll go 1 decimal place more since I'm not trying to make WebAssign happy. And then, of course, to get my bounds, I'm going to subtract that number. So 0.09 minus 0.017. And so we're 90% confident the true proportion of people that are infected with pinworms is between 7.3% to, let's see, then we're just going to add that. So second, I'm going to be lazy and not retype all that. And our upper bound is 1, so about 10.7%. And that's our confidence interval. And I said the statement in words. So we're 90% confident that the true proportion of people that are infected with pinworms is between 7.3% and 10.7%. And that's how I would write that in context. So margin of error is this calculation right here. This piece right here is our margin of error. And then I filled it in. Then this right here is our margin of error. Now, I'm probably going to show you this too, because this all can be done with an applet. I'm at that Rossman Chance applet. I have one proportion selected. I had 800 people and that were infected, and what was the percentage? What number of people were infected? 72. And there's our point estimate, the 0.09. And then we're going to do a confidence interval. We want to do a 90% confidence interval. And then notice that's about the same numbers that I had, wasn't it? The lower number looks too low. No, it is at 0.0734. So if you're going to do this and find the margin of error, because this question is asking for the margin of error, what you can do is, let's see if I can scroll this down and give us some more room. We know that this number here, the 0.0734 and the 0.1066 is 2 margin of errors wide, because we took the 0.09 and subtracted it and subtracted the margin of error, and then we added the margin of error, and that's how we got those upper and lower bounds. So without having to do all this work, we can just say, okay, so let's find the difference. I'm going to use that value right there off the applet, 0.0734, and then I'm going to divide that answer by 2, because that's 2 margin of errors wide, and we should get 0.017. Let's see if I do. So let's see, I'm going to do 0.1066 minus 0.0734. So that's the 2 margin of errors wide. Now I'll divide it by 2 to find out. And lo and behold, look what that rounds to. The 0.0166 rounds to 0.017. So you don't have to go through all this formula work if it doesn't make sense. You can just go to the applet and use the applet. What am I going to do? Let's see. Let me come back to this book and let's finish it. So we did the 90%. We'll do 99%. Okay. We'll do it by hand, and we'll also use the applet. So let me come back here. I'm going to use that same setup, except what's different here. I can let me get rid of this. Okay, so still 9%. We still have that point estimate at 9%. Now we want to be 99% confident. So if I go to that little mini table that Dr. Stevens gave us, I see I need to use 2.575 standard deviations. So 2.575 times 0.09 times 0.91, over 800, and I take the square root of that. Okay, so let's calculate this. I believe, let's see here. Well, I'll just do it. See, let's do it this way. Square root of 0.09 times 0.91 divided by 800. Okay, so that's the standard deviation. I'm going to times that by 2.575. So that's my margin of error. So 0.09 plus or minus 0.026. So 0.09 minus 0.026 and 0.09 plus 0.06 plus 0.026. So that's my margin of error. I'm between, no, we're 99% confident that the true proportion of adults that are infected with pinworms or have pinworm infection is between 6.4% and 11.6%. Whoops, let me make it a decimal since I'm being consistent. Now, if I go use the applet, same deal, except I'm going to change this to be a 99%. Notice that's the same. Isn't that the same numbers as I just calculated? 6.4 and 11.6. Yes. Okay. So I'm hoping you've seen the applet works pretty slick. So that's the first parts of this problem. If you want to stop the video and if that answers your question, I'll also do the next couple parts that ask us for the sample size. Okay, so sample size. What I'm going to do is, I think that's right. Maybe before I clear this, I better make sure that's what it was. I thought it was a sample size. Yeah. So maybe I'm going to answer part F first, since I've got that work here. Part F says in this county, it's found that about 14% of the people have pinworms. Based on my answer, does that appear abnormal? Well, it is outside of my 99% confidence interval. So yeah, that's an unusual result. It's unusually high. So yeah, something's up in Sludge County. It looks like they need some sanitation issues. But the reason I was, so, and just to make sure you understand what I did, is that point, that point estimate, or maybe I guess that's a parameter, is outside of my confidence interval. And that's a 99% confidence interval. So that's really, there's not a lot of wiggle room. So either we got a bad sample with the 72 people we picked, the 800 people we picked were just a non-representative sample. So maybe that's the situation, or this Sludge County result is really high, and they have a health crisis going on there. Okay, there's two ways to interpret that. So now let's do part D and E with a sample size. So this is about proportions. Let's see. And I don't know of a good applet that does this. So this is kind of the thing you kind of have to do by hand. Now, if you look in Dr. Stevens' textbook, let's see here. Let's go find his textbook. Or actually, before I do that, I'm going to stop the share and get that formula. Okay. So I thought I'd walk you through and show you where that sample size formula comes from. Okay. So this is the margin of error part of the confidence interval formula. That's why I left it a Z. So I'm going to solve this for n, basically. So the algebra that I'm required to do is I'm going to divide by that Z star. And that leaves me the square root of p hat times 1 minus p hat over n. Now to undo the square root, I got to square both sides of this equation. So the margin of error squared over the Z star squared. Now that's equal to p hat times 1 minus p hat all over n. And now I'm just seeing a proportion where I can do the cross products and divide, right? So it'll be z star here. Let me move this board over. If I do the cross products, I know that n times e squared, the margin of error squared, equals p hat times 1 minus p hat times the z-score squared. I'll drop the star thing. And since I'm solving for n, I'm going to divide by e. And I'm going to reorder this because I know Dr. Stevens gives it in this order. So p hat times 1 minus p hat over e squared. So that's where that formula came from. It's nothing magic. It's just the result of little algebra. Whoops, what did I just do? Let me undo this. So that's my formula I'm going to use. As a matter of fact, why don't I select that so I can use it to calculate? Okay, so for this problem, I want to be, what do I want to be here? Let's see here. No, come on, give me my board. There we go. I want to be 99% confident that the margin, they want to estimate the error that's no more than 1 percentage point. So that's the margin of error, is 1%. So I'm going to go 0.01 squared. And all right, so here we go, and that's equal to n. So a 99% confidence interval requires, I think we've looked this up before, isn't it? No, I have it here, don't I? 99% requires a z-score of 2.575. So 2.575 squared. And then we're going to use that 9%, right? Isn't the first part is use the p hat 9% as prior estimate. What this is going to give me is a smaller margin of error or smaller sample size, and you'll see that when we do the calculation with no prior knowledge, the next part. So that's my substitution in. I did p hat times 1 minus p hat, the z-score squared over the margin of error squared. And fortunately, these calculators, most of our calculators are smart enough so we don't have to do too much work with it. I'm just going to type it in as I go since there's no addition subtraction going on here. Remember, please, my order of operations. So let me get that out of the way. 2.575 squared times 0.09 times 0.91 divided by 0.01 squared. Okay, so that's the result, but remember we can't have if we round, we can't have 0.48 people, so we got to do some rounding. If we round down to 5,430, that's not quite big enough. We always have to round up when we do this. So the sample size that will allow us that small a margin of error is 1%, will be, what is it, 5,431 people. Okay. So that's the sample size calculation. The other part of it is, let's see. Let's get rid of that. What if you don't know anything about no prior estimate? So what we're going to do is come back to my formula, and we're going to get rid of the 0.09 and the 0.91 because we are assuming we don't know that. And if we have no idea about what's going on, we're going to use 0.5. 50% of the people have infected. We don't know that. And then 1 minus 50% is also 0.5 or 1 minus 0.5. And when you multiply those, you get 0.25. And that's why Dr. Stevens gives this as an alternate formula when you don't know anything about p hat. He'll use z star squared, or z squared times 0.25 over e squared. Same formula, just using that for an estimate. So now let's go back to my calculator. And I'm going to be really lazy and not retype all that, but I'm going to change some stuff here. I'm going to change this to be 0.25, and hit some delete key a couple of times. There. You see how much larger that sample is? 16,577 people you would need to survey. Much larger. So this is why in practice what they'll do is, if they don't have any idea, they'll go do some mini sample and come up with an estimate, and then use that estimate to bring down that sample size. Well, hopefully this helps you do the problem.